Okay, welcome back, Reggie Jackson. Welcome back to the homework for Wednesday night, CPM, or sorry, Thursday night, CPM 2.3.3. All right, getting the end of the chapter here. I've had a pretty long video helping you out to get started on this, but let's go over the answers now, all right? All right, that first problem, we had to finish that generic rectangle, and we knew that if there was a 30 here and a 1,500 here, that would have to be a 50. There's a 50 here and a 250 here. That makes that a 5. 5 times 4 is 20, and 30 times 4 is 120. So the addition problem they were looking for is 1,500 plus 250 plus 120 plus 20, and you add all those up, and what is the total you get? It looks like 1,890. Let's double check our work by go ahead and using the standard algorithm. Again, the problem is 54 times 35. See what we get here. 20, carry the 2, 25 plus 2 is 27. I'm going to put a placeholder because that's really a 30, not a 3. Okay, and now I'm going to go 3 times 4 is 12, carry the 1, and 3 times 5 is 15, plus the 1, 16. And then when I go add those, that makes me feel good that we got the same answer. Okay, all right, so we have a 60 here and we don't know what's here, but I have a 7 there and a 56, so what has to go there? 7 times what is 56? It's a snowman. And then this helps me get the dominoes just start falling. Is this, you get a bunch of dominoes in line, you hit that first one, and the rest will just fall, right? So 8 times 60 is 8 times 6, but move the decimal over one spot. 8 times what is 1,600? Well, 8 times 2 is 16, but I got 2 more zeros. So this is going to be 200, and that makes sense because it's 3 digits on top, right? 200 times 40 is 2 times 4, but I move the decimal over 1, 2, 3 spots. Fill in those eggs. I get 8,000. 40 times 7 is 2 times 7, and move the decimal over once. My addition problem, all these products, I'm going to get the sum. See how we're using that language now? Products and sum. And you're starting to get more familiar with those words. So you almost own those words, and that'll help you a lot moving forward, right? Knowing what they're called. So 16 and 5 is 21, 2 and 4, 6, 8, and 10 is 18, and 10, 11, 12. And let's just double check. We get 12,816 if I use the standard algorithm. 267 and 48. 8 times 7 is 56. 8 times 6 is 48, plus 5, 53, and 16 and 5 is 21. Put a placeholder. Go cross out these numbers you had that you carried so you don't get confused with the next group, right? 4 times 7 is 28. I'm carrying a 2. 4 times 6 is 24, plus the 2, 26. And 4 times 2 is 8, plus 2 is 10. Let's see if we got the same answer. We don't always. Right? The reason we double check is we want to make sure we get the same answer. And if we don't, we know we made a mistake somewhere and we go back and find out where. All right, this problem, remember you were going to paint a wall, but there was a window on the wall and you want to figure out how much paint you needed, because how much square feet of wall are you going to cover? Now I got to tell you, when you paint, it makes a difference if that wall is smooth or has lots of nooks and crannies, what we call a lot of bumps, right? A lot of texture, how much paint you're going to use, and the type of paint. So this is definitely not a perfect science when you're figuring out how much paint you need. And sometimes you got a darker or light color underneath that you got to go over with another coat or something. But let's do the math, right? Okay, so that wall is 8 times 10. That's easy, right? That's 80 square feet, right? Remember, it's 8 feet tall, 10 feet wide. That window is just a 2 by 3. So that's 2 times 3. Can't get much easier than that. That's 6 square feet. So the amount of wall that you have to paint is 80 minus 6. And how hard was that, right? I'll give you lots of hints on that one. Okay, So 2-77, we already figured out, I think all three of those, didn't we? Right? Did I give you all the answers on that? Oh, Mr. Daniel, you're being mean giving us all those answers. Make us work for some of them. You got to set us up so we know how to work when we get to 7th grade. Sorry about that. I should not have given you so much. Okay. All right. So this was a tough one. Yesenia and Misty had blocks, right? And they were base 10 blocks. So you got ones, tens, hundreds, right? And we figured out that Yesenia had 17. The value of her blocks was 17, right? Misty had 6 more blocks than Yesenia, and the total blocks was 22. Okay, so in order to figure that out, I think we figured out that Misty must have 8 blocks, and Yesenia must have, I'm sorry, Misty must have 14, and Yesenia must have 8, because that's a way you can get 6 more for Misty and still have a total of 22. Okay, so now we know Misty has 14 blocks, Yesenia has 8 blocks. We know that Yesenia's 8 blocks total, 17. Well, I don't have any 5s and 4s. I got 10s and 1s. So to get 17, she has to have 1 10 and 7 1s to get 8 blocks, right? So 1 10 and 7 1s, right? And Yesenia has 8 blocks. Sorry, that's got to go there. I'm just going to put an arrow there. Misty has 14 blocks, and the total for the two of them value is 85. So I'm going to figure out how much Misty's blocks are worth. And that looks like Misty's blocks are worth 68, and there's 14 blocks that make 68. Well, I know to get to 60, I got to use 10s, right? How many 10s make 60? 6 10s. And how many 1s make 8? 8 1s. Is that 14 blocks? It is. So that must be the answer, right? That's it. She has 14 blocks, 6 10s, 8 1s, and that is Misty. And Yesenia has 8 blocks, 1 10, and 7 1s. Boom. All done. All right. Now, on this one, you had a lot of data. We've been doing most of our data in science, but it's math related. There's a lot of crossover there where you do it in both. When you get tested in science, probably in 8th grade, most of the test questions are going to be about data, analysis, graphs, reading graphs, and figure out averages and stuff. That's the analysis. So we got all of these numbers, okay? What I'm going to do is I'm going to go straight to a stem and leaf plot, okay? And I already decided that all the numbers here, okay, are in the 40s, 20s, 30s, 50s, right? And there's a couple 60s. So I'm going to have stems of 2, that's the 20s, 3 is the 30s, and so on, okay? So let's just go through them. 44, I'm going to put a leaf of a 4. I'm going to put it not right there because I want to have room for 0, 1, 2, right? And 8, so I'm putting an 8 there. 40, I'm putting a 0. I can put it right next to it. 25, okay, and I think I already put that 25 and that 63 already done. So 28, 37, 29, 34, 45, 51, 43, 35, another 35, another, whoops, that was 45, 35, another 38, 57, 50, 35, another 35, 47, 30, 63 I already got, 43, another 43, another 44, a 60, 46, squeeze that in, 43, another one, 33, 45, another one, do that one I crossed out, 42, 34, and 32, all done. Boom. Okay, now the Histogram, that's when I'm doing groups of numbers. I'm going to do the 20s and say there's 1, 2, 3. Okay, so I'm going to go up 3, put a bar. Remember, there's no spaces between histogram bars. 1, 2, 3, 4, 5, 6, 7, 8, 9 for the 30s. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for the 40s. Past the 10. 50s looks like there's 3 again. And 60s looks like there's 2. Histogram, boom. Okay, and I'm not going to do the number plot. That's a little bit too messy, and I'm just going to trust that you guys do that and know how it looks, right? Put those numbers on the bottom. All right, good job, everybody. Hopefully you did well on this one.